Okay, so I'm excited to be here. I'm going to talk a little bit about Canvas today, and so I want to jump right into it. A little obligatory about me. I'm Jason Waters, 15 years of experience developing software. I'm one of the organizers for the AngularJS Utah meetup here. I'm really excited about JavaScript. I love Python, tacos, and my family, not exactly in that order, perhaps, but I like all of those things. And you can find me on Twitter at Jason Waters. Yep. I don't know. Does that help? Crank it up to 11. Hello? Better? Okay. So I want to apologize up front. This talk is not about Angular. My deepest apologies. I hope that you'll take the next 30 minutes with me and indulge in a little vanilla JavaScript. And then Maureen will take you through a journey of Angular again. So, Canvas. What is Canvas? Well, as we can see here, it's white, rectangular, waiting for you to paint onto it. Actually, it's just like that in HTML5 as well. Just like true to life, it's waiting for an artist to leave his mark or a programmer to script something beautiful. A lot of people are familiar with SVG. I wanted to take a minute to talk about the differences. Canvas is all bitmap graphics. You're actually going to modify pixels and draw onto a canvas element in HTML. SVG is vector-based. So since we're in the Adobe building, we could say Canvas is like Adobe Photoshop. SVG is Adobe Illustrator. The canvas is a single element that you can draw to. SVG, it actually has an inspectable DOM structure all in XML. So if you right-click in some chart or graph, you can see a structure and actually change properties on there and inspect that. It's a little bit more difficult with Canvas because if you inspect that, you just see an element that magically has a bunch of stuff on it. The nice thing about each of these things is that you can programmatically manipulate them with JavaScript. Browser support. Canvas is supported on all major browsers, especially Evergreen. If you are sadly supporting IE8, I'm sorry. However, there are polyfills available. It's not ideal. They will backfill to Flash or Silverlight. But if you're stuck in IE8 world, it could be an option. Some use cases for Canvas. It's becoming pretty popular these days. When I got my start in software development, I was actually a Flash guy. I know Flash is a 4-letter word now, so don't hate. It's over now for me. But I did a lot of games back in the day with Flash, and a lot of other people did too. Nowadays, not so much. People are using Canvas to write games. Canvas is perfect for image editing. If you're building something and you want people to manipulate some pixels, maybe crop an avatar or manipulate a t-shirt design, Canvas is a great fit. And then SVG is also a great fit here. It's usually the go-to for data visualization, but Canvas is a good option as well. And you can draw some beautiful charts and graphs with it and actually get some performance gains as well. So, without further ado, I'd like to jump in and do a little bit of live coding. I think that's going to be the fastest intro for all of us to see just what this Canvas stuff is all about. So like I said, Canvas. Big, rectangular, and white. In this case, I've used a little CSS to draw a border around it, otherwise we wouldn't be able to see it. So let's go into some of the basics. If you're going to manipulate the canvas, first thing you need to do is get the canvas element. Can everybody see that okay, or is it too small? It's okay? Okay. So we get the canvas, but we can't draw directly to this canvas now that we have the element. Instead, we have to get the context. So we can do that by saying canvas.getContext. And this takes a parameter. So you can put in, what we're going to do today is, and it has to be a lowercase 2d, we're going to get the 2D rendering context of the canvas so we can draw two-dimensionally. You can also put in a WebGL, for example, and do some 3D rendering. I'm not going to talk about that today, but there's a lot of good resources you can look at later, or maybe a future speaker. So we've got our context. I think the first thing anybody should ever draw on a canvas when they're starting out is a rectangle. So let's do that. Oops. So if you do fill rect, then you pass in an x and y coordinate and a width and a height. Now I should note that in a canvas there is a coordinate system, and in the top left is where 0, 0 is. So the bottom right, in this case, I didn't point out in my HTML, but I've defined the canvas with a width of 400 and 400. So that's what the bottom right corner is. So if I say fill rect 0, 0, 100, 100, boom, we've got our rectangle. Yes. So once you've drawn something, oh, by the way, it's a little boring. So let's say context.fillStyle, and this will take any CSS valid color. So you can put in a hex code. I don't speak hex very well, so I'm just going to say, how about that one? There we go. So it's kind of interesting because it's like, if you're thinking about a real life canvas, it's like you've got a paintbrush, you're going to dip it in the red paint, then you're going to fill. And that's what we did here. So when you have something drawn on the canvas, the next obvious thing to do is to clear the canvas, right? Do that easy enough. Clear rect. I'm just going to put some magic numbers in here. And there we go. So in this case, it drew the square and then it cleared it. Let's pull that out and make it a function. Yep.
What if you decide to clear rect 0, 0, 2020?
Yep. Yeah, it would. For the sake of time, I won't do it, but you can clear just a portion. Yeah. So we've drawn a square and we have cleared it. I think the next thing, let's move up the complexity here. Basic API. Let's draw a arc or a circle. So in this case, parameters are an x and a y. I'm going to specify 200 and 200 right in the middle. It wants a radius. So if any of you are trigonometry or geometry wizards, you're going to love Canvas. It's going to be great. And then it takes an angle and an end angle. So in our example, I'm going to say, I want a circle here, 200, 200 in the middle, with a radius of 50. And so it's going to start here. And then starting angle, I'll put 0, and it'll begin drawing clockwise a circle. So starting angle 0, let's put in math.pi. dealing in radians here. And I've saved. It's not drawing anything. Actually, it did do something. It plotted that arc on the page, but it's not visible to us because we have to do context.fill. So there we go. We've got a semicircle, and it did go in the clockwise direction, just like we said, from 0 to pi. The last argument here is anti-clockwise, so we could say true and see that it draws a circle the other way, a semicircle. So in this case, let's do 0 to 2 pi, and now we've got our circle. And of course, we can change the fill style. And there we go. Now, we could fill, or we could also, instead of fill, we could do context.stroke. And instead of filling that circle, just stroked the circle. And another thing to point out is if I take out this clear, let's change this to be 300 and 300, so our square is a little bit bigger. You can see that it drew this. Its order is in order of drawing. So it drew the square, then it drew the circle. If the circle was drawn before, intuitively, it would be behind the square. That's how it works. So, what's the next basic thing? Let's do text. Starting to see a pattern here, I think. Fill rect, fill text. You could say stroke text as well. So in this case, we'll say hello world and give it an x coordinate and a y coordinate. We have liftoff. Okay, hello world. Perfect. Although we kind of want to change that, you probably can't read it very well. So if we say context.font, now let's say 48 pixels Arial. It's much bigger now. Move it to the left. So you can do text too. Text isn't the best fit for Canvas. It's not recommended, especially when text it works great in HTML. If you see some game written in Canvas and there's a lot of text, most likely they're overlaying some HTML with text on top because performance will be a lot better. But you can do it. All right, so we've done a rectangle, a circle, some text. Next thing I think we ought to do is an image. You can draw an image to the canvas. First, we'll load one in. Okay, so I'm going to put an on load. So when this image is loaded, then we'll tell the context to draw image. There's actually a lot of different parameters you can pass in here. For this example, what we're going to tell it is take this image, draw it, this x and y, this width and height. JK. What did I do wrong here? Oh, yep. You have to specify the image. I'm surprised you guys didn't catch that for me. There we go. We've got our plumber. So one other thing that you can do with draw image, and I don't know if you can see this hinting from WebStorm, but you can specify a source coordinates, width and height, and a destination coordinates. So that makes it, everyone in here is probably familiar with sprites, CSS sprites. So you can do that. That's how when you see a game and you see a character on there and he's animating, it's because they have a sprite sheet that they're copying different frames from and putting it onto the canvas. So it looks like he's running or whatever he's doing. So that's pretty powerful. Okay. So yeah, but I didn't prepare that for the demo, so that's some personal homework for you. Yes, you can. You know what, I'm going to clear this because I just remembered that there is one more thing that you can do. Oops. Oh, it's drawing Mario on top because of the onload. Cool. We'll cheat. Okay, so you can draw a path. So if we do context.beginPath, we're about to tell it, let me give you a little more space here, that we want it to kind of freehand draw something. So begin the path, context, you'd think it would be end path, but the API designers were way smarter than me, so they called it close path. Makes perfect sense. So now if you imagine, I'm saying begin path, I want you to take a pen onto this canvas and start to draw. So first, move the pen to a certain coordinate. So context move to, and let's put in 200, 200. That seems to be my favorite. So I'm saying go to the center and then do something. And then I'm going to say start drawing a line. Do a line to coordinate 300, 300. So it's going to start in the middle, go down and to the right, then do another line, and we'll say back to 200, 400y, and of course we have to do context.fill again. Anybody know what this is going to draw? Apparently nothing. That's cool. What? Oh, I bet you it cleared it because of this. I'm going to just... There we go. Here we go. Look, we drew a triangle. Sweet. So that's how you can actually draw all kinds of creative, crazy shapes using this pattern. You specify a path, and then you plot a bunch of different coordinates for it. Okay, so we've got the basics. I wanted to spend a little bit of time having some fun, so let's go to that. We're going to build a little something. This is something I might have built in high school or something. It's to amuse myself, so it'll be useless but exciting. You can see that I've done a little bit of setup. Nothing you haven't seen. I'm getting the canvas. I've set up the context. I like to refer to the canvas as a stage that actors can be on, for example. I'm storing the stage width and height, so I can reuse that later. I've still got the clear method that we did last time. And then you often want to create some type of abstraction so you're not dealing with the metal of Canvas. It becomes kind of annoying, so if you abstract it out a little, it makes it easier on yourself. And a little bit later, I'll show you some of the libraries and frameworks that do that for you. So let's get started. In general, I like to have a function that does the work. So we'll call that function. And in there we'll call draw circle. this abstraction allows me to say an XY and a radius and a color. So in this case, we'll say, why not map? Well, no, we're going to switch it up a little. Yes. Okay. Great. Demo over. Oh, no, I'm just kidding. So we're drawing, but if you've got a canvas and you want to do something cool instead of just draw it and leave it there, you want to draw and draw and draw a little bit more. So in this case, we can say window dot set interval draw one. So it doesn't look like anything new is happening, but what it's doing now is it's calling draw over and over and over and over and over. That allows us to tweak what draw is doing so that each time it draws again, something could happen. So to do that, let's make a definition of a ball. And instead of having some magic numbers like we have here, we're going to define those. We're just going to move those magic numbers for now. Okay, great. We can see a lot of progress here, can't we? So it's drawing. One common thing that you do if you're building a game, for example, or any type of animation, is you start dealing with velocities and accelerations. So I'm going to have this ball store its own velocity. So I'm going to say x velocity is 1, y velocity is also 1. So in a positive direction, technically it should move there. So we can say draw the circle and then do so if we do that, well, there we go. It's drawn. Great. We just took the paintbrush and slid it along. Can do the same thing here with y and y velocity. Now it's actually still drawing. It's going and going and going. It's just off canvas. So that's kind of annoying. And it's also annoying that it's just a big smudge. So what we'll do is we'll start by clearing before we draw anything. And there you go. You probably almost missed it. But it's drawing, clearing, drawing again. That gives us the sensation of the ball moving. So one thing that I forgot to mention was that you should never do this. Set interval is a bad idea in this case. It's really inefficient, and you're probably going to draw and update way too much, way too frequently. So there is something else that browsers can offer us now, and that's request animation frame. Request animation frame is essentially doing the same thing, but it's deferring to the browser, saying, you let me know when it's the best time to animate something. So it's a lot more efficient. So I'm calling it here, and then it has to kind of recursively call and call and call in order to make the animation go. So you can see it's actually a little bit smoother there if we increase the velocity a bit. So it's kind of annoying that it just goes right off the screen. Let's fix that. We're going to do some if statements. Let's say if the ball dot y, so the y of the ball is right the middle of the ball. So if we say the ball y coordinate plus its radius is greater than stage height, then let's take the ball y velocity and set it to negative ball velocity. There we go. So it bounced off the bottom, it's still going off into space on the other side. So we'll repeat this a few more times. If ball.x plus ball radius, the right side of the ball, is greater than stage width. I'll copy this because it's so similar. Then we'll change the x velocity to negative x velocity. So, it's pretty simple algorithm here. It's just saying I'm just going to keep adding the velocity, whatever that is, and then we're saying, nope, switch that when something happened. Okay, if ball dot, let's go off the top. So if the ball y minus the ball radius is less than 0, ball dot y velocity equals positive velocity. Okay, one side left. If ball dot x minus ball radius is less than 0, all right, let's see if it worked. There we go. Bouncing ball. Everything that dreams are made of. Thank you. There's more. There's more. It's going to be great. It gets better. Okay, so this is kind of annoying. I mean, what if I want more than one ball? Well, I could just copy and paste about 15 more times, right? Or we could do something cool. So what I'd like to do, ideally, is say new ball, for example, up here. And then down here, every time it gets through this update loop, we'll call ball.update and ball.draw. This is actually a very common pattern if you're building a game like this, because this is a game, where the update method is going to update the state of the object. The draw method is going to deal strictly with drawing it. So this is not going to work yet. So what we'll do is we will change this to a function. And let's see. I'll replace a few things. Okay, so we've got our ball definition as is. Let's say ball.prototype function and ball type draw is a function. I told you it was vanilla JavaScript, didn't I? This is great. Love it. Okay, so now what we need to do is take this logic we wrote here and actually put it into the ball. The ball should behave itself. So we'll take this drawing line and put it in the draw method. I'm going to change ball to this because it's a property of this instance. And then if we take, this is mostly the state change logic. So we'll pull that out of there as well. Put that in update. So update is going to just update the state of the ball and the velocity. This is refactoring, guys. Sweet. I would write tests, but that's boring, so we'll stick with this. Okay, think it'll work? Crossing my fingers. Let's save that. See, once again, making so much progress. Still works. Looks exactly the same. So one thing we could do to spice it up here is let's have the ball start on a random x coordinate. I've imported at the top here a low-random method. You've probably all used it before. It allows you to specify a minimum and a maximum, and then it picks a value in between. So in this case, I want it to be random on the x-axis, keeping in mind the radius at about the radius. So we'll say this dot radius. Speaking of that, let's move this up as the min, and then stage width minus radius for the max. That ought to do it. Let's make the radius random too. Random from, say, 5 to 4. And then, so 5 to 20. We'll see if that did anything. Look at that. It's a small ball. Nice. So we got something going on. Let's do the same treatment for the y-coordinate. Oops. So now you can see it kind of just randomly positions itself and gives it a random size on the stage. Let's make the velocity random. I mean, random is just, this feels right, doesn't it? Wow, it's too fast. 2 to 10. 2 to 8. I mean, I can't take the speed, guys. Okay, and then lastly, I have written oh, you know what? I also wrote another thing, random negative. This is, so what we had before was it would always be a positive random x and y velocity. Passing in this little random negative multiplier, it's going to give it a random negative. Maybe it will be negative, maybe it will be positive. And so the ball could potentially go in and see how it went to the left that time. Truly random. And then orange gets a little dull. So get, what did I call it? Random, of course. Random hex color. Okay, I had to refresh it a few times. I'm colorblind, so I was hoping it was changing. Looks like it is. It's great. Perfect. Okay, so now we've got the scaffolding all set up just in time, because now we can start repeating ourselves and make ball 1, ball 2, ball 3. That's not recommended. Instead, we could create an actors array and instantiate a whole bunch of balls in here. And then down here we can say, for each actor in this array, call update and draw. And there we go. Look at that. So, you know, it's nice. We can instantiate however many balls we want. So let's, crank it up. Yes. Screensaver, people. This is great. And we can get it even more. So you can see, actually, performance is okay if I'm 1,000 objects all at once dancing around. If I crank that up to, 5,000, it's not so good. So there are limits with Canvas. So there you go. Okay, I know I just have a few minutes. Just give me 2 minutes. And let me finish this presentation. So now you know everything you need to know about Canvas. Pat yourself on the back. Okay, just kidding, there's a lot more. But now you got a taste. So here's a little homework for you if you're interested. There's some frameworks and libraries out there. Easel.js is a great one. All of these are interesting. Game engines. Impact is a very popular one. And then if you're interested in reading more about Canvas, this book is a great one, Core HTML5 Canvas. There's a YouTube video diving deep into Canvas. Highly recommend. And if you're into React, I know it's a 4-letter word here too, I'm sorry. But they've got React Canvas, which will render a React app to a canvas, which is pretty cool. That's it. Thanks, everybody. These are the URLs if you want to get this slide deck, a bit.ly link there, so you can get to all those things I skimmed over. And if you'd like to toy around with the example that I just built, you can find that on my GitHub. I know we're out of time, but are there any quick questions before we end? Okay, thanks everybody.